Guys, welcome back to these reports. We're looking at Lake Mead and Lake Powell today, but the Glen Canyon Dam at Lake Powell now has trouble. And there's been a major shift in the data. We're going to break it down, but there was an investigation released last night or this morning at 4 a.m. by the Colorado Sun. They are confirming that engineering teams at Glen Canyon Dam are managing an active cavitation issue inside the river outlet works. We're going to look at that and a few other things and look at some of the new numbers. But guys, this cavitation was not supposed to happen until about another 35 feet drop at Lake Powell itself. And as we said, Shannon Moulin of the Colorado Sun released this at 4:12 a.m. Mountain Daylight Time this morning. Again, saying supercharged bubbles are threatening Lake Powell's dam. Federal officials are battling to sustain water levels. And back in the 80s, they had the same exact problem, except the reservoir was overfull, and they were having to let out so much excess of water that it created holes in these. They're basically concrete covered rebar outlet tunnels. Some are 16, 17, 18 feet wide each in these tunnels. But in the 80s, when they had to release everything to keep the water down, and they made a mistake and they learned from it. But what they did was they were trying to peak off Lake Powell. And they didn't know how much snow was going to fall, how long it would last. And so they just held it and held it. Then when finally all of the snow melt came down, it was more than the dam could handle. So they had to let it out the emergency flow gates, and it ate into them so hard that rebar was exposed. The red sandstone coloration was in the water. Big hunks of concrete were being pushed out. They knew they were in trouble. Now, the exact opposite is happening with the same results. And let's look at this. At low water levels, more air from the reservoir surface can be mixed into the water. Ideal conditions for bubbles to implode with destructive force as the water travels through the tubes and turbines. And this year, the reservoir's water level is extremely low. Federal reports show that the dam may have to stop hydropower generation before the end of the year. Now, we've been talking about it getting into very low levels here in, late fall, possibly early winter. But they're talking about complete shutdown of hydropower. Now, again, they may have to stop hydropower generation before the end of the year to avoid catastrophic damage caused in part by the small but mighty bubbles. The way this works, under extreme compression, it creates quite an explosion. It says the Bureau of Reclamation has spent millions of dollars adding protective layers to some of the dam's water release valves. They had to go back and do some of that repair from the 80 very high water release, guys. But state and federal officials are debating how to manage around the dam's limitation as part of a high-stakes negotiation this year. The bad thing about it, back in the 80s, they had time to rebuild. Right now, they don't have time to rebuild. We were already in trouble before this happening as far as ordering new turbines at Mead or whatever it was. All of that was not going to occur for a couple of years, and by then, basically, the rivers are back to normal. It says after a record poor winter snowpack, the Bureau is searching for more answers to an increasingly concerning question. And it is key to changing all the numbers you and I have looked at since May, looking at the drops, figuring the daily elevation drops, all of that, the inflow, outflow. But what they're doing now, they have to keep the water level high enough to avoid severe damage in the middle of a brutal drought, while meeting obligations to send water downstream for millions of people like Phoenix, Vegas, and Los Angeles, and the farmers who grow the nation's food. And just to give you an idea, guys, of how strong this cavitation effect is, going back to that almost collapse in the 80s, it said eventually they could slow the flow through the spillway down enough to inspect them. The water finally got enough out. Experts paddled a raft into the bottom of the tunnel and drop down its steep throat from above using a cart tied to a cable. That would be a very high-paying job, in my opinion. Anyway, final inspections reveal broken steel bars, guys, rebar. Ripped apart concrete lining that they found holes 20 feet wide and up to 4 feet deep. A gigantic pit 32 feet deep, 40 feet wide, and 150 foot long. That's how it ate into the surrounding surface after it ate through the rebar and concrete. Simple air bubbles under high compression and high heat. It would eventually take about 2,500 cubic yards of concrete to fill it, enough to fill an Olympic-sized swimming pool. The dam wall wasn't going to rip apart and let Powell flow into the Grand Canyon, Wagner said, but its spillway failed and the hydropower plant could have been lost too. He said they did everything they could to minimize the disaster. But what they learned is that if they had known how much was going to fill up, they would have released water earlier in the year. But they were trying to save as much as they can, but it just kept coming. But they learned that lesson about the early releases, and if you can look forward far enough to see what is going to come. But right now, it's just the opposite in the current situation of our desert. Glen Canyon's dam problem in 1983 was too much water. The lake's elevation eventually rose to 3,707 feet above sea level. That was 7 foot above the official capacity of 3,700 feet. That's why they had to have the emergency releases. Now it has the opposite problem, too little water and the host of issues that come with that. Glen Canyon's dam's main job is to store water and release it through the Grand Canyon to Hoover Dam, which then releases it to millions of people. And after 25 years of drought, the spillways aren't even part of the conversation now. The lake's water level is too low. Dam managers must depend on two main release options, the turbines and the small Still River outlet tubes. And there's a big concern with low water and turbine releases. As reservoir level drops, whirlpools could start on the lake's surface. More air can get sucked into the flow of water, and vibration and surges of high water pressure can occur, according to the Bureau. We call it cavitation. If tiny bubbles start collapsing with explosive force, this is how it works, guys. Within the turbines, that's a problem. The turbines are finely tuned with a spinning propeller inside. If they wobble even a small amount, it could knock the turbine out of balance, causing speeding propellers to rip through the turbine walls and wreak catastrophic havoc on the hydroelectric facilities all through that big hall where they line up these turbines. But they're in the basement of the dam, these turbines are. Because of everything that's connected to them, you would likely see large-scale destruction in the power plant itself. And Wagner continued, he said, it's not good to have cavitation in the turbines. It's not good to have cavitation in the spillways, and it's not good to have cavitation in the pipes. And that is the problem they're having now. The Bureau has said for years that it wanted to keep a cushion of water in Lake Powell to avoid these problems. That meant keeping the lake above 3,525 feet in elevation. As of May, the lake's elevation was 3,527. By December, it could easily fall to 3,510, according to the Bureau's projections. Now, if Powell gets too low, guys, they have to send water, not through the turbines. Instead, they will be forced to channel the entire Colorado River around the turbines and through the 4 96-inch river outlet tubes for months or longer. Think about that. The cavitation will start eating into that very quickly. These tubes were not designed for sustained high-velocity flows, especially at low lake levels. In 2023, Reclamation reported minor cavitation damage to the aging coal tar coating after a high-flow experiment meant to benefit native fish populations and environments downstream. They started seeing it then. The Bureau spent $8.9 million on a new protective coating to the tubes. saying it was part of a routine upkeep, not specifically cavitation protection. This new lining has already been successfully applied to numerous dams, including Fontana Dam in North Carolina, Pineview Dam in Utah, and the Grand Coulee in Washington. And they're saying that the Bureau, especially at Glen Canyon, they are not experienced in managing low water levels. They're used to the opposite. Now they're caught between a rock and a hard place. They have to make sure water reaches downstream communities, and they can't risk expensive damage or safety issues at the dam. It's going to, whatever they do, it more than likely will be a temporary prop-up. Now, we talked about that for years, the different organizations, the different tribes, state, federal, have argued over the water rights, and now the feds have given them to October 1st to come up with a plan that works, or the feds will completely step in. But it says they must create new rules for how to manage Glen Canyon Dam and other key dams going forward. The Bureau has already released different management options, each based in part on preventing damage at the dams, especially from what? Cavitation. They are seeing this is the great danger. Those high-stakes negotiations have been deadlocked for years over potential painful water cuts during the basin's driest years. The new rules must be in place by October 1st. And guys, I think this is why this thing came out at 4 o'clock this morning. It says the Bureau is avoiding the dangerous tiny bubbles by cutting releases and sending emergency water from upstream dams. Both will help avoid extremely low water levels in Lake Powell. In other words, they're going to drain Flaming Gorge. It's a temporary solution. They admit it. These emergency releases shrink upstream reservoirs and can hurt marinas, boat rentals, and businesses around the reservoirs. Plus, once released, the jig is up, especially when you've got El Nino setting in and no more snow coming this winter. But the Bureau can't tap those reservoirs next year unless this water comes with enough snow to replenish it. But the low release downstream brings the basin's 7 states closer to a legal tripwire that could trigger lawsuits. Said this before, all of those will be temporary and useless because the river does not have a judge. It does not have lawyers. It does what it wants to do. And it would possibly force water cuts in upstream states like Colorado, the experts are saying. Some say paying the basin's largest water users, mostly farmers and ranchers, to use less water is the most affordable way to refill the lake. And they've tried it, guys, but the math just hasn't worked out for them too well. And really, it's when you're looking at, again, a great change on the planet, some of these things are very temporary prop-ups. It says Colorado and other upstream states have tried this, and the water savings were minimum. Just 1% of the state's annual use is all that was saved after all that money going God knows where. The political debate is fiery. Upstream farmers don't want to shrink their business to help Lake Powell or Glen Canyon Dam. Of course they don't. Guys, you know, we've got folks that watch our videos that are up at Flaming Gorge. Again, they don't want to sacrifice everything. The farmers don't want to shrink their business to help Lake Powell or Glen Canyon Dam. In that case, meat either, because their conserved water they've been saving will just be used by people downstream. In D.C., a bill to refund the program has been stalled for months. Now, maybe people at that level understand what's going on and realize that it is useless in a lot of ways. And here's where some of the other things become pipe dreams. And I've seen it where people say, well, why don't we can build a pipeline from Canada down to the U.S.? Why can't we build one from the Great Lakes? Guys, do you realize how long that would take, how much infrastructure it would take, and how much damage would be past history by the time any of that was completed, if you could even get it funded? Do you realize? I hope you do. But others are pushing for more permanent solutions. Again, to me, they're pipe dreams. Replacing the aging turbines. Guys, why? Why? When the river's taking itself back. With new models that can operate better when the lake's level is low. are building new tunnels that can move water around the dam when the lake is extremely low. These tunnels would avoid damage at the dam while still allowing water to reach communities across Arizona, California, Nevada, and 2 states in Mexico. And I see the scope of that, and I see the reasoning behind it. But I think it's going to take much more time than what we have now, but I do see that eventually happening. Nature may be the one that opens the outlets. We'll just have to wait and see. But now what they're saying, and this is Eric Balkin, the executive director of the Glen Canyon Institute, he's saying the whole system is now being hamstrung by this infrastructure problem at Glen Canyon, both above Glen Canyon and below. We've been saying that for many years, and now the lower basin states are saying the same thing, guys. And they are, again, if you remember when we started this series, the Bureau of Reclamation had stepped in and they said, we're going to limit the downflow from Lake Powell down to Meade to 6,000 acre feet or something like that. Then they quickly raised that after a couple of weeks, realizing they just made another mistake, and they jumped it back up into the 9,000 and 8,000 cubic feet per second range because Meade was dropping too fast, and they knew it. But let me show you what they've done now because of this morning's report. Now let's look at Lake Powell just a moment. Last 14 measurements, and it's right in track with Lake Meade. It's down 1.97 feet over these 14-day measurements, just under 2 foot, right? A foot a week. Now Meade has accelerated. It's about 2.19 feet every 14 days now. But here's what happened. You got the report at 4 a.m. that started coming out. And last night, guys, and Sunday, July the 5th, we had been seeing for the last several days here, the inflow from Powell be around, it averaged 44.38 for the 14 days. We saw it winding down. It started 65, 47, back to 60, and then get into the 30s, and here get into 28.37. This is cubic feet per second inflow. And then suddenly they had to double overnight. Look at that. From 45 to 8,079, 4,505, almost doubled because the water was getting so low. It's about to go into the cavitation setup, and they already are seeing these bubbles start to form. That's why we're doing the video. But here again, they had to quickly do something right there to get more water into Powell, at the same time not releasing as much in downstream into Meade, slowly cutting it back from 78 to 76. Averages 83 though on the 14 days. So they're going to limit the outflow to Meade, double the inflow from upstream, Flaming Gorge, and anything involved in that area. But how long can Flaming Gorge and those guys take a doubling of their outflows? Because they're low also. But this was the prop-up point from the article we're reading to try to save Lake Powell. Now, the Bureau of Reclamation is studying this and other low water management options at Glen Canyon Dam since 2023, but they're still saying their report will not be final until 2027. We're not a year or two away, we're a couple months away. But as an engineer, again, they're saying, I can tell you we can redesign the dam, but it's going to cost you money. It's going to take some time. Millions and millions of dollars. A lot of time for what? So you can set up on a high dam and look at the river flow 200 feet below you? He recalled a day in '84 when he once again, at the bottom of the dam, the water had come. The spillway was being repaired as a historically large snowpack once again built into the mountains. And he said he looked down into the Colorado River and saw a foot-long chunk of concrete. He's kept it ever since to serve as a tangible reminder of what can happen when things go wrong with improper planning. And if you try to change the native habitat from what it was designed to be, that's how it works out. The lower basin, guys, we're talking about Powell and Meade, is not a static pool. It's a high velocity conveyor belt of water moving down to massive agricultural empires and municipal water hubs. The moment the feds restricted Powell's outflow, this was going back about a month ago, the transit delayed work in reverse. Within days, the physical volume entering the head of Lake Mead shriveled. Remember, I said they stepped in. We're going to cut Mead's supply to 6,000 acre feet, and it didn't work out. This is what this is about. Because Hoover Dam was still forced to discharge over 8,000 cubic feet per second to keep municipal taps flowing in Vegas and crops alive in the Imperial Valley, the lack of upstream inflow caused Mead's elevation to enter at an immediate, nonlinear freefall. The feds realized within days that their Save Powell maneuver was going to crash Mead's grid infrastructure almost instantly. Now it's going to be even faster. But guys, a third grader could do the math on input and output. Guys, your inflow rate, half of your outflow rate, and you playing with these numbers, that's elementary math. Why are these engineers having so much problem with it? Is there another reason? Maybe all the information, if it came out too quick, people would handle it differently. Who knows? Guys, and we've been dealing with this for a couple months, but right now, the newest threat, just today, again, the federal reports confirmed that supercharged air bubbles are actively threatening Glen Canyon Dam at Lake Powell. Because Lake Powell's water levels are so dangerously low, massive amounts of air from the reservoir surface right now as we speak, guys, are being drawn down and mixed directly into the intake tubes. When this aerated water passes through the tubes, it causes severe destructive cavitation. When tiny vapor bubbles implode with immense force, violently pitting and tearing away the steel and concrete inside the dam's river outlet. To prevent a catastrophic structural failure of the dam itself, engineers may be forced to completely halt power generation or drastically throttle water releases downstream. The moment Powell throttles back to protect its pipes, Lake Mead inflows drop to zero, causing Mead's decline to curve to shift from a gradual slant into a vertical plunge. That, like dominoes, one trigger, even though they're all starting to collapse, one additional point of pressure, and it will speed that entire crash system very quickly. Now remember, this is happening as we speak. These supercharged air bubbles are threatening Glen Canyon Dam right now. And what's happening is because the water line is hovering dangerously close to the 3490-foot minimum power pool, there isn't enough physical water depth above the massive penstock intakes to suppress surface physics. What are those surface physics? Remember, it's like a reverse tornado, a vortex, or a whirlpool. The cavitation engine, the intakes are pulling water with such immense velocity that they create powerful, downward spiraling whirlpools that reach all the way to the lake's surface. These vortices literally gulp massive pockets of air straight down into the internal steel tubes, just like a hurricane or a tornado, guys. As those compressed air bubbles travel down into the high pressure zones of the tubes, they implode with explosive force called cavitation, tearing chunks of metal right out of the dam's primary plumbing. If they warp a turbine blade, it cannot be closed, it cannot be shut off. But it can get out of balance enough to destroy that entire level of where the turbines are. And again, they're getting cavitation way too soon. Originally, the engineers calculated that severe cavitation within the main power generation loops would not trigger until the reservoir dropped to exactly 3,490 feet. And that's where you get into what they call minimum power pool. Now at Lake Mead, remember, that's at 1035. We're at 1038. Okay. Anyway, this was the designated line. So why is it doing it now? Maybe 30, 40, 50 feet before this point. Again, it has to do with the bottom being full. So there's not that much real water depth There's a lot of sediment compressed. It says, in the original blueprints, this level was meant to be an absolute structural red line where the 8 main turbines must be shut down entirely to protect the dam from self-destruction. But it's starting to happen now. So will the dam have to be shut down entirely? Because if you get into the turbine system and you start getting critical errors and pitting, even on the guide blades, they can't shut them down at that point. And like I said, if they get out of balance, they will destroy the entire hydro center section of the dam. It says today's crisis reveals that the engineering models fail because cavitation is starting much higher, catching the Bureau of Reclamation completely off guard for 2 specific reasons. And they're calling it a 20-foot safety buffer that has evaporated. The center lines of the actual generator intakes, called the penstocks, sit at 3470. When engineers built the dam, they established a 3,490 foot as a safe 20-foot column of water resting above the pipes to act as a physical weight. They believed that 20 foot of water pressure was more than enough to suppress surface physics, again the whirlpools, and keep water moving slowly into the turbines. Now what else happened last night? We did a video talking about record high pressure coming over the Rockies called the 597 degameter, right? And if you remember near the end of the video, I was talking about that high pressure, guys, will push hot air all the way down into the lowest valleys. It has the same effect on water. So they weren't counting that. And when I say Mother Nature will come from all angles with no quarter, this is exactly what we're looking at. The reports came out that almost within 24 hours of each other. This extreme pressure above us is pushing down on water. Even with the lake technically hovering above the minimum power pool, right now, the sheer speed at which water is being sucked down into the penstocks is overpowering the shallow water column pressure. It is creating powerful, localized vortices, whirlpools that rip straight down from the surface and gulp air directly into the lines long before hitting the 3,490 foot floor. Guys, do you realize how close we are to shutting down the hydro at Lake Powell? Now, over the last few years, the Bureau of Reclamation has saw that the lake was going to get very close to 3,490. They tried to get ahead of the problem by routing massive amounts of water through the River Outlet Works, the ROW. The 4 smaller 96-inch backup bypass tubes located lower in the dam. We talked about it. But the shocker was, as of today's reports, during experimental high-flow releases designed to bypass the turbines like we're dealing with now, the water moving through these narrow backup steel pipes reached such an extreme velocity that it triggered severe, unexpected cavitation directly inside the plumbing. The high-velocity flows created micro vapor bubbles that imploded inside the steel walls, pitting and eroding the metal infrastructure from the inside out. Now you would say, well, how does a micro vapor bubble do all that much damage? I'll show you. Guys, and if you want to search this up for yourself or for a report or just for your own knowledge, just type in, can cavitation micro bubbles reach high temps? And it says, yes, collapsing cavitation microbubbles can reach extreme localized temperatures. Guys, listen to how extreme. Now you'll know where the destruction comes from. During their violent implosion, the gas and vapor inside the bubbles can momentarily reach temperatures ranging from 2,000 K to 10,000 K. Guys, that's 3,100 degrees Fahrenheit to 17,500 degrees Fahrenheit. That is hotter than the surface of the sun. Under pressure, these implosions and dropping that many feet, imagine hitting and imploding with minute implosions at 17,500 degrees. It melts it away. It's like sandblasting, but it's super high temps. Guys, and you've seen it in your boats. You ain't got your prop all the way down in the water. You can see your prop get eaten up pretty quick by this introduction to air. But the mechanism, it says, when a microbubble collapses under high pressure, such as in an acoustic field or downstream of a pump blade, the compression is so rapid the heat doesn't have time to escape. This causes the internal gases to spike to thousands of degrees. The hot spot, despite these enormous temperatures, the effect is highly localized to a microscopic scale. Because the superheated area is confined to fractions of a micrometer, the overall bulk temperature of the liquid remains almost completely unchanged, typically rising by 0.5 to 2 degrees centigrade. Now, the sudden release of localized temps and pressure is even accompanied by a flash of light, a phenomenon known as sonoluminescence. It is also responsible for generating high-velocity microjets that are powerful enough to pit and erode solid metals in industrial settings, like a dam turbine. Now, going back to the original plans of the Bureau, the protocol, or the shutdown protocol, was if the water line against hits 3490, the federal government must completely lock down the 8 turbines and cease all electrical generation. This instantly wipes out 1,320 megawatts of baseline electricity off the western grid. And they're calling it the human target. This sudden shutdown cuts off clean federal hydropower for more than 5 million people across 6 states. The hardest hit will be rural electric cooperatives, native communities like households in Gallup, and municipal districts in New Mexico, Utah, Colorado, Arizona, Nevada, and Wyoming that rely entirely on this low-cost baseline power. So they're already making plans now, guys, to switch from the cheapest power on Earth, hydropower, to some of the most expensive out of necessity. Instead of going completely dark, your light bill could triple. In other words, just saying. And they're saying that households in the Southwest must budget for a permanent, sharp increase in utility rates as providers outbid each other for expensive, short-term natural gas and market power to replace cheap federal hydro. They've got the fraction backwards, let's say that. They're admitting that the Southwest, the households there must budget for a permanent sharp increase in utility rates, right? But they're talking about short-term natural gas and market power to replace cheaper federal hydro, as if the hydro's coming back, but that because of natural gas is not a infinite, like a product like they thought water was, the prices will go up and the resources will go down. But they're going to be transitioning homes to maximum energy efficiency, guys. And you know how I feel about that. You cannot transition anything unless you have enough water and electricity. A house in the desert without either is no place you can survive. We've talked about how there's going to be a lot of delinquency in loans by people simply handing over the keys because you can't sell a house in the desert under those conditions. So there's going to be financial problems wrapped up in all of this mess. Now, because of losing that much hydropower, guys, you're going to start to see kind of what we're seeing now start. Because utilities will use intentional rolling curtailment, blackouts to keep old transformers from exploding. And you can't have 24/7 runs without the night cooling. Families must prepare for localized power interruptions during peak summer afternoons. Having a household emergency plan, including a reliable battery backup system to help medical equipment, refrigerators, and baseline communication lines that can help keep them alive for at least 24 to 48 hours. They make those, you charge them with your panels and all, but you're limited on what you can do with them. A home-based system is much better because you have so much more power built into a large battery bank. But to do this, it is essential for riding out infrastructure strain. That's why I continually say, guys, prepare. Prepare. It's coming. It's right here on us. And the only way to make it is to prepare, whether it's you may want to relocate or store up on water or food or solar or whatever it is. But if you just sit there and wait for it to happen, it's going to be too late when you realize that you needed to make a move or make some preps. And let's take a quick look at Meade. Now, they've got a problem a little different. Again, they're down 0.2 feet. That's just yesterday, and it was 1043.69. It's not dropping fast per day right now because they're having to either increase inflow or outflow and try to balance it all. But we're still at 2.19 feet per 14 days, over a foot a week. Here's the problem. The downstream demand from Phoenix and other areas like that, agriculture and all, is they're having to put out 14,229 cubic feet per second, while intaking half of that. So again, you've got a problem setting up there. And what happens to the 7161, guys, if because of cavitation, they have to shut down a good portion of Lake Powell? Do you see how that will be totally non-linear on the scale that we were looking at? It will get into real world numbers very quickly. And there we could see an advanced timeline for both Powell because of cavitation and because it will be forced to cut off Lake Meade because of that. So these dates, we're looking at the end of August, things like that, may get much closer than we're talking about for a couple reasons. Again, when you start having your middle reservoir, which Lake Powell was the middle reservoir, second largest in the nation, and the battery for Meade, that battery charger's getting lower by the day. Now let's look at the 14-day measurements of Lake Meade. Again, Lake Meade is down 2.18 feet over these measurements. That's 2.9 feet 1.9 feet every week. 2.18 every 2 weeks. And here's what we're looking at. Started out as the average for the 14 days, an inflow of 8,772. But it actually began right here, 9176. Do you remember when they stepped in and made Powell shut down some of the outflow and forced this around 7,000? They thought that would be the permanent spot. It lasted about 2 weeks, and the Bureau realized at that time they had a little more on their plate than they had realized. But at, again, 9176 was about where they jumped back to keep Meade up. But now, look at this. They're back down 2,000 cubic feet per second, almost exactly, because Meade is having to cut back to save it from cavitational destruction. Think of that. And the temperatures are not giving anybody any relief in that area at all. But guys, we're watching this. I thought I'd bring that up. We look at all the data. And when you start talking about cavitation tearing down the second largest reservoir or taking it down in the nation, it is definitely a data point. But we're watching it, guys. You watch it. It's a major heads up. Remember, our Father loves you. We love you. The world loves you. It's a heads up. Be safe.